we're live, Tony. Hooray! Well,
Yay!
Welcome to everyone. Thank you so much for joining us today. It's an exciting day today because it's Tony's first webinar with us. Hooray!
Woohoo!
Thank you so much, Tony. So Tony is today presenting an end-to-end example with EventStoreDB. Take it away, Tony.
Thanks, Natasha. Hey, everybody. As Natasha said, my name is Tony Young. I'm a senior solutions architect here on the field technical services team with EventStore. And this is my first webinar, so happy to show you all an end-to-end example with EventStoreDB. So my background is primarily in the data and analytics space as a consultant and architect. So blending a little bit of tech with a little bit of business and trying to kind of bring the technology to a particular business, working with organizations to implement technologies and build them into their business workflows. So I'm really excited to be at EventStore. And even more excited to show you sort of an end-to-end working example that you can get started with EventStoreDB and event sourcing. So what I'd like to show today is start by talking about the problem space we're going to use for our example. So we're choosing loan processing, super complicated area at most big banks and most financial lenders, but we're going to boil it down to something simple that we can work with as a concept and show off all of these things that we're going to be doing with event sourcing. We're also going to talk about some of the benefits that you would get by using event sourcing to solve a problem like this from both a business and a technical perspective. And then we'll walk through the actual process of performing event storming, building an event sourcing diagram that will turn into an event-driven architecture. We'll talk about how we implemented this. I'm going to show you what we've done with Python, but there are lots of languages you could choose from. We'll give you a nice demo. I've got a little surprise at the end of that demo to show everybody. We'll talk about some downstream use cases of what we could actually do with this example and EventStoreDB in general. And then we'll talk about some next steps to get everybody enabled and get you started on your EventStore journey. So as I mentioned, our problem space here, we're going to choose loan processing. Our goal here is really to find a problem space that brings together and allows us to go through all of the concepts surrounding event sourcing, and that would be event storming, building an event-sourced application, implementing code, working with EventStoreDB, the event native database, and using all of its technology in the right way. Now, loan processing is something that most, if not everybody, is familiar with. A lot of us have credit cards or have applied for home loans, student loans, payday loans, all that kind of thing. So it's a fairly large problem space that everybody should be familiar with, fairly relatable. As I said before, it is generally very complicated with a big bank, but we're going to boil it down into some very simple business rules that I have listed here on the slide. So for our example, we're going to assume that our loan application is going to contain some data fields submitted by the requester. We'll get into what the specifics of those fields are as we work through our example here. There will be a credit check that's required. So we'll simulate actually calling out to an external system, getting back a credit score. And based on that credit score and our loan application data, we'll work towards some automation where if we have a credit score greater than or equal to 7, we'll approve the loan automatically. Less than or equal to 4, we'll deny the loan automatically. And otherwise, we'll send off for some manual decision-making for approval or denial. And we'll show you what that looks like with things like read models and underwriter, human in the loop being involved. Now, don't worry if all of these terms are kind of new, or you're wondering, well, what the heck is this event storming thing he keeps talking about? We'll step through those in time as we move through our material today. So it's important to note, especially for those of us getting started with event sourcing, that event sourcing is really meant to support your business workflows as well as your technology partners. So this isn't just something that the IT team thinks is super fancy and, hey, we want to do this brand new way of implementing. This is something that's going to bring benefit to the entire organization as we work together to implement a new business process. So event sourcing on its ahead is going to make our solution fully auditable. So we're going to have a durable trail of all of the steps taken in our loan application and our loan processing. Our data doesn't get changed. It doesn't get removed by mistake. There's this sort of time order creation of our events, and we can time travel through that application process, seeing what happened at each step along the way, performing auditing, looking for places to do to perform process improvements, things like that. And we can do full auditing right down to the individual event level, the individual action level. So very valuable, for both the technology as well as the business. Our solution with event sourcing also delivers highly, fully granular data with very rich context. There's nothing to lose. There's no summarization. There's no summary table here where we kind of take the best bits and boil it down. No, our event contains exactly what happened in full, great, gory detail. And we can then have no limits applied to the downstream processing of those events. If you need the full rich context for something, you have it. If you need to summarize it, you can do that and provide only that information that's necessary. Now, over time, our loan processing workflow will likely evolve. The business will learn things, the workflow will change, they'll ask IT to make changes. Event sourcing really allows easy integration between our processes. So changes that I make in one part of the workflow are easily absorbable by other parts of the workflow. Our components can change in isolation without impacting each other. And our systems are also fault tolerant. So if a part of our workflow, let's say the credit checker crashes, things pile up and just wait until that process comes back online, where they pick up their queue, process all of the data, and catch back up. Now the business gets to change its mind. How often have we heard, well, to make that change, it's going to take us 6 months. We have to go off and do all kinds of analysis and rework. It's a lot simpler with event sourcing because we have this set of loosely coupled processes that are all working together to solve a common problem, and we can make rapid change to one very easily. Now, we have no idea what technology is coming down the pike. AI has taken the world by storm over the last little while. Event sourcing really allows us to future-proof our solutions here, so that if we want to send that data down to a new analytics tool or a new AI tool, a new ML tool, whatever it is, whatever the new technology of the day, we have all that data. It's all available in its raw form, ready to go. We can transform it into whatever format we need for those new technologies, and they're all of a sudden enabled. So let's look at an example here, starting from the very beginning. We've defined our problem space. Now we want to go through the process of event storming to build this event sourcing diagram. But before we get there, let's talk just a few definitions for the folks that might be new to these technologies, as I was just a few months ago. Event sourcing is a software development pattern. With this pattern, we aim to model the actions or commands that are taken within a particular system as a set of events that are produced by that system. In event sourcing, the source of truth is always this set of events. So we're not looking to a particular database table. We're looking to the collection of events that have taken place that capture the facts of what happened, all that detailed information, that rich context I was talking about. And the state of our system can be derived at any time by collecting together and processing in order this set of events that took place. Now, event storming, on the other hand, is a workshop-based method where we determine the commands, the events, the business workflow, how we integrate with external systems, etc., that we want to model. And we want to model this at the end of the day as a software system. It's really a free-flowing discussion about the workflow. So we bring together physically the business and the IT teams. We let them talk, ask questions, and share information around. Most organizations that do this actually do it with physical sticky notes that you put on a board. They're colored. We'll talk about what the colors mean so that we all understand kind of what bits of the process are happening and what we're modeling. We move things around. We expand on some things. We collapse others. We look for optimizations. And what we arrive at the end of an event storming session is hopefully a fully fleshed out business workflow that we can then go off and implement as an IT team in code. So it's really a partnership. It's an opportunity to bring these two teams together that sometimes aren't talking the same language, bring that shared collective wisdom about the business process as well as the technical realities together so that folks can arrive at the best solution. So how do we get started with this? The best way is the simplest way, and the simplest way is to ask really open-ended questions. What are we here to collaborate on? Your business people will reply and say, well, we're talking about building a loan processing system. Okay, great. Well, from a high level, what do we want our loan processing system to do? Well, we have consumers. So you can see Tony, the actor, sitting here in the cloud that's going to apply for a loan. And our system will then generate decisions to either approve or deny that loan, and then head on back and notify the customer. So right here, we have the very beginnings of our event sourcing diagram of our workflow. We have Tony, who's going to perform an action or a command, which we represent with a blue sticky here, to request a new loan. Along the right-hand side here, we know that Tony's loan will either be approved, so that's another action, or denied, which is a different possible action, and Tony will be notified. That's what the arrow here is leading us to. Okay, so already we can start to build out this diagram to document our workflow. Now, how do we get from request to decision? Because obviously there's a huge amount of meat in the middle there that we need to kind of fill in. So our IT team would probably ask something along the lines of, how do we determine if a loan should be approved or denied, right? Very open-ended, start a free-flowing discussion, let's talk through it. Well, an underwriter might look at a loan application as well as the credit score of the consumer, and then make the decision to either approve or deny that loan. So here we have a little bit more information that we're pulling out. We know that there has to be some system in which an underwriter can look at a loan, and we represent a system with a pink box here. So we have our underwriting system. We also know that the underwriter needs to look at the loan application and the credit score. And so we call that a read model. That's presentation of information stored as events in some transformed way that a human being could look at this or a machine and make a decision. So we represent a read model in green. And that read model is connected to our underwriting system, which is in pink. And based on the output of that read model and system, based on some action taken within that system, we'll perform the commands to approve or deny our loan. Okay, so we're slowly building this thing out. But what about that data that the underwriter needs in order to make their decision? Right, a person's got to have some kind of information in front of them in order to process it and take a decision. So, our IT team is going to ask what kind of information that underwriter needs. Well, to protect a consumer's privacy, the business probably collects as little information as possible. So things like name, address, the amount of the loan that they want, and so we know now the kind of information that comes in an application. Now, if the IT team is probably going to say, okay, well, that's great, but I can't just have this jumble of all kinds of different application information. How do we keep those applications separate from each other? And so, there's generally some application ID assigned. So our business will probably tell us there's a unique ID number assigned to each loan application, so consumers can apply for more than one. Each of the loans is kept separate for privacy as well as approval reasons. Okay, so that's great. So we know right now we've got lots of data coming in, right? Their name, address, amount of the loan. We're going to assign a unique number. But how does that number get generated? Well, from a business perspective, we don't care as long as it's unique. Okay, so decision point here, the IT team can decide how those are generated and probably how best suits the technology chosen. So as we're building this diagram out even farther, now we know a couple of other things. We can add this orange sticky here, which represents the information submitted through my loan application. This is an event here. Tony applied for a loan that generated an event with all of this detail that I supplied as part of my loan application. I know that that detail is fed into my green read model here, so we connect those two. And I also know that once my loan is approved or denied, I'm approving or denying a specific loan. So that loan request ID will be captured as part of the approval or denial event that takes place when the underwriter makes their decision. Okay. Now, if you have been paying attention, you heard me say at one point the business combines the application with the credit score. Well, how do we get to that credit score, right? So we're missing a little piece of the puzzle here. So we ask the business, how do we get at a consumer's credit score? Well, we use their national ID number, and we go and check that against the credit clearinghouse to return a credit score back to our system. So right here, there's a piece of missing information. We didn't know we needed to capture a national ID number. No problem. This is an iterative process. So we should also capture that national ID number as part of the application. Yeah, things get missed. So yes, let's add that to our application. So you can see as we're processing through this, we're building out here our loan requested event to include the national ID number. And now we have a couple of other interesting pieces here. We've got this purple box here. And purple box is a business rule. So the business rule tells us that we need to take that national ID number and check the person's credit score. So the business rule invokes a particular action or a command here, which is to check the credit score. That involves calling another system that we have represented in pink, the credit clearinghouse. So it's something like an Equifax or a TransUnion, perhaps. And what we receive back is a response that gives us the person's credit score. And then we want to hold that in yet another event to say, hey, the credit was checked, and this is the credit score for this national ID number. And we also know that we need to feed that into the read model presented to our underwriters, right? So now we have a line from this credit checked event and from this loan request event. So now we have all the pieces of information that underwriter needs to look at our loan and take an approval or denial action. So we're almost there, but one of our business rules is that we have some fairly standard policies around when things are approved or denied. So if you're looking at this as an IT person, you're probably saying, hey, there might be an opportunity for some automation here. So this is a great time to ask the business, can we introduce a little bit of would the underwriter under any conditions automatically approve or deny a loan? Well, this gets the business talking and thinking, right? In practice, a consumer with a credit score of 4 or below is always denied. That's always just too much risk. We don't take that on. A consumer with a higher credit score of 7 or above, well, we generally always approve those. So if we were to introduce some business logic to automatically approve or deny a loan based on that specific range of credit score, would that be acceptable? And of course, the business is going to say anything that can take some work off of our underwriters' plates would be very welcome. They're really quite busy. So, business rule here defined. So we can further expand our diagram here. Now, this is much more complicated. I apologize, it's a little bit of an eye chart here, but Natasha was kind enough to send out to registrants the PDF copy of this slide. And we'll also make sure that we post this into our samples repo after the presentation today. But what we're seeing here is we've got all our standard bits, right? We've got our loan application, we've got our credit check, and now we have this extra box along the side, this extra business rule, right? So this is what's going to perform that automated decision of approval or denial, or hey, I can't handle this, I need to send this off to an underwriter. And that expands our diagram significantly because now we want to make sure we document every possible path through the set of business rules. So I'm going to add a few extra actors here. I've got Eve, Tony, and Rob now. So Tony's path remains the same. I go off for some manual underwriting. manual approval or denial. But we do have this business rule here that says, hey, Tony's credit score falls within that range that I cannot automatically approve or deny. And so a loan approval needed event is generated before any further action is taken. Now, perhaps Eve, who's applying for a loan, his credit score is really good. So Eve goes off and the loan can be automatically approved. So, a command taken there, which generates an automatic approval event. And perhaps Rob's credit score is too poor to be applied. And so we automatically take the decision to decline Rob's loan and automatically deny that. So with this, we have accurately captured all of the simple business rules that we had set out in our problem domain. Obviously, at insert large bank or financial lender here, this diagram would be much more complicated, lots of other decision points, lots of other workflow pieces. But for the purposes of our example here, we've captured what could be considered a fully functional loan processing system. So you're looking at this and you're saying, well, great, Tony, we've got the workflow down. This is really helpful. But how do I turn this into a thing that I can actually build? Well, at this point, what we want to do is start transitioning this event sourcing diagram off into more of an architecture diagram. So if I look at my workflow here, there's thousands of ways that I could break this up into components that I could implement with event sourcing. But as I look towards architecture, excuse me, there's really four main parts to the solution. On the left-hand side here, we have some system that's handling submission of applications and reporting of status back to the person who requested the loan. So we'll call this, application submission or loan requester. We then have in the middle this big meaty part, which is performing, that credit check, that integration with an external system. We need to do the credit checking, so you can kind of encapsulate that business rule and action into one single thing. Along the right-hand side, this is where we take decisions, right? So there's a business rule there, an automated rule that gets applied. I can approve it, I can deny it, or I can't make a decision here. And then we have our underwriting system where manual decisions have to be taken to say I'm manually approving or manually denying this loan. Okay, so four main components to our system. So what this is going to look like from a process perspective is we're going to have our loan requester here. And this is what a person is going to interact with to apply for a loan. I'm going to fill out my application, put in all my particulars. I'm going to click, some submit button. That's going to cause an action for me to actually apply for the loan. And it's going to submit a loan requested event that's going to be placed into EventStoreDB, which is the event native database sitting here in the center. From that, I have my credit checker that's going to pick up and say, hey, I hear that there's a new loan that's been applied for. I'm going to perform a credit check against that. I'm going to go off and integrate with that credit clearinghouse. I'm going to return a credit score and that'll generate a credit checked event, which will go back into EventStoreDB. My loan decider then is going to pick this up and it's going to say, all right, now I get to apply my business rule. I can either generate a loan automatically approved, loan automatically denied, or a loan approval needed event. And if a loan approval needed event is created, my underwriting system is going to kick in and say, hey, I need to get all this detail about the loan application and the credit score, present it to a human being, let that human being take a decision about the loan, and they will either produce a loan manually approved or loan manually denied event. And once those events are back in EventStoreDB, then the status is presented back to the end consumer. So before I jump into any implementation details, Natasha, are there any questions at all sitting on the line?
No questions as of yet.
Okay, great. So we'll just jump forward then.
Okay.
Okay, so we've done our initial, pardon me, implementation using Python. So Python as a language, super simple to write code, very readable, executes on pretty much any platform that you can think of. So we chose this to work with EventStoreDB, the event native database, as our data store. Our Python client is fully supportable. There's lots of other languages that you could think of adapting this into, things like our .NET client, our Java client. I think there's one for Go and a number of other languages. But you'll find all the code we're working with today, except for our super special surprise. We're still working on that. But this is all in our Event Store samples repo that you can find up on GitHub. So do please take a look at that code. If you want a working example, you can clone that and get started. So let's jump in for a quick demo here. I'm going to, just to get set up here, I've got 4 different terminal windows. And I've also got this Python application that builds a GUI here that I'm going to show. So I've got 4 terminal windows because we've got 4 different processes to work with. I'm going to do some test injection here. I'm not going to submit 4 individual loan applications. The reason I'm doing that is because I want to be able to kind of talk through things as the system is flowing. So in the bottom right-hand corner here, I'm going to start my underwriting process. So my underwriting process, this is the one where a human will actually interact with the system. If there's a need to manually approve or deny a loan, they'll get a read model and they'll be able to take action on it. In my bottom left window, this is where I'm going to have my automated process that's deciding on loan decisions or on loan applications here. So this is the one that's going to apply that business rule to say if you fall within that range, that needs manual approval, go off to underwriting. Otherwise, I'll take an approval or a denial step. In the top right, I'm going to place my credit checker. So this one is the one that's actually going to go and check credit scores. I'm going to pull my window back over here. I'll show you why in a second. And now at the top of my top left here, this is where I'm going to manually inject a bunch of loan applications. So we're going to use this test injector because I'd like to be able to kind of talk through all the steps. So we'll kick this off. And the minute I put a loan application in, you'll see that my status reporting window up in the top right here says there's a new loan requested. My credit check process runs, and it picks up that a credit has been checked. My loan decider picks up that application and says, hey, this is a great credit score. I can automatically approve this loan, and the process finishes. The next one gets submitted. We can see the credit has been checked for that. Our loan decider is here and says, hey, this is kind of in that middle range. I need to manually approve that. So we send that off to underwriting. You can see our underwriting window here now has a presentation to an underwriter to take a look. I'm not going to do anything with that just yet. We're going to let the system flow. So my third loan application has come in. It also, based on credit score, needs some manual approval. So we can let this one sit for a second too. And our fourth loan request has come in. The credit score has been checked. And we can see, based on that, poor Rob, his loan gets denied. And so we can see loan automatically denied. Okay, so very simple example. There's one event store database sitting behind this, kind of allowing the events to flow through. So what's happening from a technical level, my loan requester simulates a person actually hitting that button to request the loan. So all that information is encapsulated in an event, and it's appended into a stream in EventStoreDB. My credit checker is listening for new loan requests. It's waiting for new loan requested events. Once those events come in, it's going to pick it up, take its action, which is to call out, simulate a call out in this case, to a credit clearinghouse. It's going to return that credit score as an event into the same stream, so it's associated with that same loan request. My loan decider down here in the bottom left This is listening for credit checked events. Once we have a credit checked event, we know we have an application and a credit check. We have enough information to process that business rule, so it can now pick up that stream and say, is there enough information here for me to, there is enough information here for me to act. Is the credit score good enough for me to automatically approve, or poor enough for me to automatically deny? Or do I need to send this off for manual approval? And we have our underwriting system here that is sitting waiting for loan approval needed events. And once it picks them up, it's going to present those to an underwriter. So let's interact here. So if you notice in the top right-hand corner, I've got two loans that are sitting here needing approval. So my underwriting system presents both of these loans to me one at a time. So this is what we called our read model. This is presentation of all of the data associated with Tony's loan. So as an underwriter, I take a look at this and I say, okay, well, I'm ready to take a decision. So what is the approver's name? Let's say the approver is John. And do you want to approve this loan? Well, yeah, I know that Tony guy. He's pretty cool, so we'll approve his loan. So once we approve that loan, you can see my status up top has changed. So this status window is simply following all of the events generated in the system and is able to update its read model, its presentation of status of all of the loans every time it gets a new event. And that happens basically instantaneously, right? So we can do a similar thing with the next one. All right, I'll take a look at David's loan. Something in this loan application I don't like. So I'll say my name is John as well, but no, I'm not going to approve David's loan. We'll deny that one. Sorry, David. So now we see a loan manually denied event has been created, and we see our status is updated up here in the status checker window. So we're able to walk through all four workflows very, very quickly and very easily with this test injector. And in a real running system, you would have lots of these applications coming in, the credit checks and automated decisions take place. And we have this buildup of manual underwriting that's required, and we can kind of process those as required. Lots of ways to kind of fan this out to multiple underwriters at the same time, but for the purposes of our simple example, that's we're not going to show that. But I do want to show this actually happening in real time. So I'll apply for another loan. Let's say that Natasha here wants to apply for a loan, and we'll just make up Natasha's national ID number. The amount of loan, let's say Natasha wants $10,000 or euros, pounds, I think, actually, Natasha, you're in the UK. And maybe Natasha's address is 1234 get out of my way in my city, my region, my country. And we'll use a super special postal code that we have here in Canada, which is ho, ho, ho. This is actually the postal code to send a letter to Santa at the North Pole. And before I submit this, I'm just going to copy the loan request ID, and I'll show you why in a moment. So I'm submitting Natasha's loan request, and you can see instantaneously it shows up in my status window here. My credit checker picks it up, checks Natasha's credit. It's generating actually a random number in the background here, so I don't actually know if she'll be approved or denied. Looks like her loan was automatically approved, so we don't go to underwriting in that case. But what I do want to show you is, suppose as a consumer, this process would probably take a little bit longer than it shows up on our example here. But suppose I as large financial institution want to provide some kind of AI-based chatbot where the end user would be able to say, what's the status of my loan, or hey, I made a mistake. I want to kind of update things. Well, I have a super special example here I want to show you. We've been playing around with how to get this stuff integrated with AI. And it turns out that we can actually feed these raw events straight into something like an OpenAI model and get detail back from ChatGPT. So I'm going to start my OpenAI example here. Excuse me. So my example code here is asking me to provide a loan request ID. So you think about this from a tech workflow. You know, uh, Natasha might be logged into her loan application portal. The portal would probably know about all of her different loan requests and would be able to provide this, but we need to do it because the code, is kind of disparate here. So we're going to provide the loan ID, and what's happening now is that the system has gone off and it's pulling events straight from EventStoreDB, and we're simulating doing it one at a time so that we can kind of ask some questions. So our question from Natasha might be, hello, I submitted my application. I'm wondering if you can give me a couple pieces of my application information because I think I might have made a mistake. Oh, and by the way, what's the status of my application? So with a little bit of fine tuning of the model, we're trying to tell the OpenAI model, don't give out Natasha's national ID number because that's very sensitive information. And based on the loan or based on the event types, what is the status of her loan? So you can see here, I'm sorry, but for privacy reasons, I can't give your national ID number. But here's the country in which you applied for. If you need to update anything, let us know. Okay, so we're interacting directly with ChatGPT at this point. So the next event perhaps is generated. Natasha comes back a little while and says, "All right, this is taking a while. Where's my loan? Why isn't it being processed yet? What's the status of my loan?" So ChatGPT is able to turn around and say, well, the current status based on the event type is that the credit has been checked and we're awaiting an automated decision. So in this case, what we've done is we've told with some fine tuning OpenAI that a credit checked event means that the credit has been checked and now we're off into that automated decision. So we can kind of fine tune that model based on the event type, the type of event here, to say where the application is in the loan application process. And it's able to actually successfully pull out the date on which we requested the loan because we told it what a loan requested event means, right? It means that this is something I applied for. So the next event in the stream here that Natasha received was that her loan was automatically approved. Congratulations, Natasha. So you're asking, when did I request my loan and what's the current status? And again here, with a little bit of fine tuning, the model is able to fully interpret that raw event as well as the type of the event, and give a response that is accurate to say, hey, your loan's been approved, and this is the time at which you requested your loan. All right, so again, all this happening right in the background. The power of Python is really to pull these raw events from EventStoreDB. You can see this operating in real time. In my example, it's not real time. I'm stepping through the queue and pushing those events with some fine-tuning data into OpenAI, and then asking through ChatGPT a series of questions. So interacting directly with that model based on the raw events and actually generating proper responses. So, AI, obviously the hot topic these days. Everybody wants their AI models to act on real data in real time. And with the power of EventStoreDB, the event native database, you can get there really easy with that combined with an event sourced application. But that's not the end of it. Your downstream consumption of EventStoreDB's data can look like anything. So from our perspective, these events can either be sent in raw form, so like what we just did with the OpenAI integration. You could also be listening for events and sort of transform them, summarize them, and put them in some downstream database where you could perform, analytics or BI and reporting. So, very common to build an ODS for reporting. So we might take those events, build them into some summary table and detail tables, and then allow folks to go off and run their Tableau reports, their Power BI reports, etc. And as those new events come in, we can simply do that transformation and update our ODS so those folks can get real-time access to that data. Similar thing on the ML side. So suppose we want to have some ML model that is constantly listening and learning, and we can ask it for ways to do process improvements. So we can stream those events into our ML models. It'd probably take a little bit of transformation, no worries. Put them into that ML tool, and then perhaps out of that we get some recommendations to improve the workflow of our loan processing system, some changes to our business workflow that'll hopefully make everybody happier. So, next steps. How do you get started with your own project, with your own implementation using EventStoreDB? Well, I'd recommend you get started by learning about event sourcing, event storming, and EventStoreDB as well. You can find lots of resources out there on the internet. To be totally honest with you, it seems really daunting and overwhelming at the start if you're just getting started, because there is so much information out there. It feels like you're climbing a mountain to kind of get on top of all this information and really learn the concepts and the details. Don't hesitate to reach out to us here at EventStore. We're happy to help you navigate that. It's not as hard as it looks, I promise. I was brand new to this space only a few months ago, and been able to get on top of it relatively quickly, and I know you can as well. Please do check out our GitHub sample repo. You can see all the code. The AI stuff's not quite ready, so we haven't quite put that up yet, but the fully functioning loan processing system code is up there, written in Python. We hope to get other language versions of that out soon as well, so do watch for that in our repo. We've got a quick start video series that'll be landing over the next few weeks, where you can learn lots more great depth and detail about event sourcing, event storming, about the basic concepts of EventStoreDB. So do watch those videos. We're happy to help answer questions, but lots more technical detail in those as well. I didn't really cover any of the technical nuts and bolts of this system during the webinar, but we will be covering them in the videos, so please don't hesitate to watch those. If you want to learn about EventStoreDB, the event native database, you can catch us at eventstore.com. Tons of developer content, lots of enablement materials up there as well. And please engage with us through our community. The Discuss, Discord, Twitter, and much, much more you can find at eventstore.com/community. And I hope to see you there. Thanks very much for your time, folks. And if anybody has any questions, I'm happy to take them now.
Wonderful. Thank you, Tony. That was awesome.
Thank you.
Yeah, that was wonderful. Well done on your first webinar.
Much appreciated.
As Tony said, if there's any questions, please ask them now. But if you do think of some maybe afterwards, please get in touch with us and we'll be happy to help you. Seems like there are no questions, Tony. So well done. Thank you ever so much for everyone for joining us. And until next time, thank you so much, Tony.
Thanks, everybody. Bye for now.